Hey everyone, I am making a video about conservative forces, how to prove they're conservative, and then how to find the f of x in which it was derived from. So we're given this f here, it's really long. Uh, we have a I, j, and k component. Sorry, k is a little cut off at the end. So the first step is we're going to prove a conservative, and I've already written out some steps that are kind of helpful. So we know that a force equals f sub xi plus f sub yj plus f sub zk, and the f sub x matches up with m, f sub y matches up with n, f sub z matches up with p. So I'll kind of show you how what m and m and p are really. Uh, and then these are the three equations right here you have to do to prove that it's conservative. So if it passes each three of these, therefore it's conservative. And you do these by matching it up with the M, N, and P components. And to better understand what this means is if we're doing the partial of M with respect to Y, we're really doing the partial of the partial of F with respect to X with respect to Y, and making it equal to partial of M with respect to X, so it's really the partial of F with respect to Y with respect to X. And this, you can simplify this down by saying it's partial squared over partial y partial of x, partial squared f, partial of x, partial of y. So if we're doing the partial of m is the partial of f with respect to x with respect to y, and partial of n is the partial of f with respect to y. We're doing partial of that with respect to x. We're pretty much just doing the same thing to show that they're equal. So we're doing the partial squared of f over with respect to y and with respect to x. And for the first one, you do x then y. The second one, you do y then x. And this is just to prove to you that these came from the same f. So if all three of these are equal, that means that they have to have derived from the f. So since we know that no matter the order in which you do the partials, if you do the same number of partials with the same, like with respect to the same variables, the equal number of times, you're going to get the same thing. And so so we do these all three times with each of these other two equations, essentially to prove that it all comes from the same f of x, y, z. Because the fx, fy, fz all come from this f here, some f of x, y, z we don't know. And if we're able to show that doing the partial again with the same, but in different orders, with all three different combinations, then we're able to say with confidence that that all of these components came from the same f of x, meaning it's conservative. If you have a different component, it's not coming from the same f of x, y, z, meaning that there's some other contributor to the force that's either neglecting it or adding on to the force. That means it's not conservative. So like if one of these didn't equal, that means that some component of that force did not come from the same f of x, meaning that it's not conservative. I know I kind of went into a little bit more detail than you really need to know about it, but if you're able to understand this, then what you're doing here, it's not just something you have to memorize, it's something you can understand. But with that being said, I'm going to get started. And these are my favorite problems to do. Out of all, every single problem in Calc 3, doing these are my favorite. So to prove that it's conservative, and do the partial of m respect to y. So if we had this is m, this is n, this is p. Ooh, my bad. All right, so then I can do partial of in respect to y, so it would be partial of 2y squared z e to the 2x with respect to y. That would equal 4y z e to the 2x, which should equal partial of n with respect to x. So this right here, the right term in the n does not have an x in it, so that'll go to 0 if we do the partial of n with respect to x, but the one on the left will not go to 0. So we would do the partial of 2y z e to 2x minus z squared sine y with respect to x. That will equal, you're just taking a derivative of that e to the x there. So we're going to get 4y so 4y z e to the 2x, which does equal, so partial of m partial of y equals partial of n partial of x is true so far. So then we do partial of n with respect to z. So you partial of 2y squared z e to 2x with respect to z, which equals 2y squared e to 2x, as e just goes to 1. And this should equal partial of p, which is 1 over z plus 2z cosine y plus y squared, which is e to 2x. All that with respect to x. That should the two terms left should go to 0, and so then you'd be left with 2y squared e to the 2x. Then partial of m with respect to z equals partial of p with respect to x. And now partial of n with respect to z. Partial of n, which is 2yz e to 2x minus z squared sine y. So that would equal, okay. So this would equal 2y e to the 2x, because the z would just go to 1, minus 2z sine y. And that should equal partial of p, partial of p, which is 1 over z plus 2z cosine y plus y squared e to 2x over the partial of partial of y. Let's write that partial of y. So that should go to 0. This term, you just take the derivative of cosine y. So we have 2z, derivative of cosine y should be a negative sine y. Now plus 2y e to the 2x. Alright, so that's equal, even though the terms are switched, you still have the same signs. So partial of n respect to z equals partial of p respect to y. Therefore, f is conservative. And just doing that is like is a big component of this problem. Like, even though it's pretty straightforward, you have to do it always. So make sure you know these equations. Make sure you can at least understand how to get them. The reason why I did these color scheme is to show that every time you do the 3 different combinations of M, N, and P, your x would always be across from your n, your y would always be across from your n. So you have to make sure you do all three of these pairings in order to, this is a good way to memorize it and not forget it. So hope that helps for the conservation part of this. So the next part is we have to find fx, y, z. So in order to find fx, y, z, this is a three-step process you normally have to do. You first find f of x, y, z from f sub x. Sorry, I'm going to sneeze. Never mind. No, I'm not. Sorry. So we can say that, so to define fx, y, z, here, let's get going through it. To find fx, y, z, we can say it's the integral of m dx, which is the integral partial of f with respect to x dx, which makes sense. We're only taking the integral with respect to x, so everything else can remain constant that isn't, an x. So then we get part of this f of x, y, z, when our plus c, our constant, will be some function y, z. So with the f of x being, or m being 2y squared z e to the 2x dx, the integral will end up equaling y squared z e to 2x, because we divide by the derivative of 2x, which is 2, so we just divide by 2. And we have our plus c, so our plus c is instead going to be a function of, it's labeled g, that is a function of y and z. So if we found this, we have like a part of our f of x, y, z function, but we're missing the g, y, z. So in order to find g, y, z, we take the partial of f with respect to x of this equation, of what we just found. So when we do that, we can then say that that'd be equal to 2y squared. Sorry, not partial of x, partial of y. Sorry, the partial of f with respect to y of what we just found here. So it'd be 2y z e to 2x plus dg over dx, or you can say g prime of yz. Whatever indicates that this is a derivative of gyz. Sorry, I shouldn't do a prime. My bad. Partial g, partial y. It's a partial of g with respect to y, and we set this equal to the partial f partial y, or n we have in the original force, which is equal to z squared sine y, that's negative, plus 2y z e to the 2x. Since it said it equaled this to the n component here, we can see what's left over as a function of, that is like the partial g, partial y. So we can see what was lost when we did the partial of x, where we didn't lose when we did the partial of y. So what I mean by that is we set these two things equal to each other which we did here, and find what doesn't fit. So if we have these two terms here and cross these out, so we can then say partial of g partial of y equals negative z squared sine y. Then if you took the integral of that, we can find gyz, which equals the integral of negative z squared sine y dy, which would then equal z squared cosine y plus some function of z. So the reason this is some function of z is because that's the only thing we haven't taken the partial of yet. So because we know this is some function of y and z, and when we take the integral with respect to y, we're gonna bring back some constant value that may just be a constant or have the variable z in it. So that's why we have to label this as a function of z. So then we have this, and this is equal to g z. So this can go into that. So we have part of the puzzle. So now we have to break it down even more. So we do the same thing that we did. We found the partial of f with respect to y, but now we have to do partial of f with respect to z with this. And when we do that, we also have to include the what we found earlier. So we say, to rewrite it, we have f of x, y, z equal to y squared z e to 2x, plus our g of yz, which is z squared cosine y plus h sub z. So now when we find partial of f with respect to z, take the partial of f with respect to z for each component. So then the first component will go to y squared e to 2x, simple. This will become plus 2z cosine y. And this the hz, so where I messed up in the last part where we had two variables, I took the partial of it. I can't say g prime, but in this case I can say h prime because we're taking the partial of something that only has just that variable. So the partial of h with respect to z is equal to the full derivative of the h of z. So then I set this equal to our p, or our partial f with respect to z, and that's all up here. So we're going to see what we're missing from this, and just by looking at it, I'm going to guess that our h prime is going to equal 1 over z, because that's the only thing that doesn't include an x or a y in it. Plus, I think these two are already included. So I'm going to say this is equal to, let me look at my paper, because I can't remember what I just looked up there. We have y squared e to 2x plus 2z cosine y plus 1 over z, which is equal to p, or partial of f with respect to z. So then we see that these two match up, cross these out. See that this 2z cosine y matches up, cross these out. So then, like I said before, h prime of z is going to equal 1 over z, which implies h sub z, oh, that's a terrible z, but whatever, equals the integral of 1 over z dz, which is equal to natural log of the absolute value of z. And since this is our last variable, we have to count for any constant that's just a number. So we have to say plus c. So now we've accounted for every variable and any possibility of our partials for our m, n, and p, and we found each function within a function, kind of. We have f of x, y, z, and there's a g, y, z in there, and then for the g, y, z, you had h of z. Now we've broken down h of z to being just an equation with a constant. So now we can bring f of x, y, z together and say it's equal to the top part, which is y squared z e to 2x, plus our g of yz, which is z squared cosine y, plus our h sub z, which we found here, which is natural log the value of z plus c. So then this is our function f of x, y, z. And typically this would be the end. Sometimes they'll ask you to find something like this, f dot dr, where you go from 0, 0, 1 to 1 pi over 2 e. And no, I did not pick these numbers randomly. These are numbers they actually used on a previous quiz. And for this f of x, y, z, so since we said that this is like and this is equal to the integral of df, which is equal to f. So we are able to just plug these variables, these limits straight in, meaning that this is the integral. The integral of f dot dr is x, y, z, is f the function of f, x, y, z. So let me erase that. So this would equal y squared z e to 2x plus z squared cosine y plus natural log of absolute value natural log of z from 0, 0, 1 to 1 pi over 2 e, and they probably made it work out really well. So we plug in that. We have for x we have e times 1 squared times, what was that, e squared times e, so this is e cubed. Man, I don't like that at all. So this is for the first term. We plugged in all the things because we had, oh wait, it's y squared. Oh my god, this is awful. Sorry. So this is going to be e squared, z is e, y squared is pi squared over 4. Sorry. I don't know what I'm doing. There we go. Yeah, making sure I'm doing this right because this looks ridiculous. All right. Now z squared is e squared cosine pi over 2, which I think God is going to go to 0. Plus the natural log of e. So go to 1. That's the upper limit minus the lower limit. So it's going to be 0 for that. Plus cosine of 0, which is 1, so plus 1. Plus natural log of 1, which is 0. So plus 0. And we're going to end up getting sorry. So we're going to end up getting pi squared e cubed over 4. Since that's a plus 1, then we'll have a minus 1. So it equals pi squared e to the 3rd over 4. Make sure they're right. Yep. Okay. So the main takeaway from this is how to get conservative forces. And it's to know that you have to match up all the different partial pairings with each other. So whenever you're matching up with n, you have to make sure you do the partial of n respect to x equal to partial of n respect to y. And the same things go, the different pairings go up for p and m and p and n. And also knowing that since like the m, n, and p are all functions like they all derive from the original function f x y z. So doing the integral of either, like if you do doing the integral of f sub x with respect to x gives you your function f x y z. But since we can't, that thing does not account for like the g, some function of g y z, because if you take derivative of g y z with respect to x, this will go to 0 because there's no x in it. And the same thing can be said for h sub z when we try to find out g sub yz. So we take the integral of partial of like the partial of g with respect to y. We take the integral of that with respect to y, and you have to account for some function of z plus a constant you don't know. And you just gotta keep this doing over and over again until you get down so you have your final function plus a constant. Whatever it is, like you can plug them all back in. So this is h sub z, so this goes into h sub z. This is gyz, and that goes into your gyz. So then now, like this is how you get your f of xyz. I know it's kind of nondescript way of saying it, but this is like a process. It makes a lot of sense if you do it a couple of times, and it's all about going back to this f of xyz that you originally got this force from. So, hope this helps. Comments below for any questions. Make sure to put a timestamp on it. Yeah, really hope this helps. Good luck on your test.